All right, we're going to start with graphing absolute value inequalities. And so first, what I want to talk about is go or law. And again, if you have learned this before, great. If you've never learned this and you don't want to use it, that's fine too. But I use the word go to represent the greater than or the greater than or equal to symbol, and then the letter O to represent the word or, so that when I split these two inequalities apart, I'm going to separate my two inequalities by the word or. So let's take a look at number one. So number one, the absolute value bars are isolated already. And so how I'm going to split or get rid of these absolute value bars is by writing my two inequalities. And so the first inequality is going to be x plus 3. And we're going to write this same inequality symbol, so it's greater than or equal to 7. Now to write my second inequality, I need to figure out, well, which word am I going to use? Because I used the greater than or equal to symbol from my original, I'm going to use the word or to separate my two inequalities. So when I look at my symbol after I've isolated the absolute values, that's going to be what determines the word I use. So I'm going to use the word or. And then my second inequality symbol, write it just as I see it, just like equations. So x plus 3, but I'm going to flip the symbol. So instead of greater than or equal to, it's going to become less than or equal to, and I'm going to flip the sign. So instead of a positive 7, this is going to become a negative 7. Now I'm going to solve my two inequalities separately or together. Doesn't matter. You use the same step for both problems, but your result is going to be different. So I'm going to start out by subtracting 3 from both sides. So I get that x is greater than or equal to a positive 4, or I get, after I subtract 3 from both sides, that x is less than or equal to a negative 10. So negative 7 minus 3 gives us a negative 10. Notice how the arrows are now pointing in different directions, and so they're going to go away from each other. When I go ahead and start plotting these, I want to look at this part right here. I need to find my symbol. So because I have a greater than or equal to symbol, which follows here, anytime we have an equal to symbol, when we go to graph or plot this on a number line, we're going to use a closed circle, showing that not only can x be larger than 4, but it can also be equal to 4. So I'm going to use a closed circle here. And notice how my arrow is pointing to the right. So I'm going to draw my arrow to the right. So this symbol should match the arrowhead. And that'll always be true as long as your variable is on the left with inequalities. In the same way, my other inequality, notice I have the less than or equal to symbol. So because it's equal to, I'm going to use a closed circle over negative 10. But now notice how my arrow is pointing to the left. So I'm going to draw my arrow to the left. So this arrowhead should match the same symbol as my less than symbol. So how we would read this is that all of my solutions to this inequality are going to be less than negative 10, or they're going to be greater than positive 4. In the same way, we have number 2 over here. And in this case, we have just the less than symbol. So we have the absolute value of 4 times x is less than 12. The absolute value is isolated already, so we can get rid of the absolute value bars by writing our two inequalities. So my first inequality is going to be 4x is less than 12. Because that is the less than symbol, I'm going to use the word law to help me out. L stands for less than, and A represents and. So when I go write my second inequality, I'm going to separate them by using the word and. Now, I'm going to flip the symbol and flip the sign. So instead of 4x is less than 12, I'm going to say 4x is greater than negative 12. Flip my inequality symbol and flip from positive 12 to negative 12. From there, again, just solving like normal. So we're going to divide by 4 to undo that multiplication. And as you see, I'm going to do that same thing over here. So same process, but a different outcome, a different result as our solution. So here we get that x is less than 3, and we get that x is greater than negative 3. Now when I go to plot these, referring back to our open circle, closed circle, because both of these symbols do not have an equal to symbol, I'm going to use an open circle, meaning it can get really, really close to being equal to 3, like a 2.99, but it cannot be exactly 3. So I'm going to put an open circle at 3, and notice how my arrow is pointing to the left, so I'm going to draw my arrow to the left. Over here at -3, I'm going to use an open circle, but notice how that arrow is pointing to the right. So I'm going to draw that arrow to the right. Notice how they meet together. And so how we would read this solution is that all of my solutions, all the values of x that are possible in my original absolute value are going to be somewhere between -3 and +3. So they meet together.